So, now we will discuss about connection of cells or combination of cells, series and parallel connection of cells. You have learned connection of resistors, series connection of resistors, parallel connection of resistors, mixed connection of resistors. Now, we will learn that same combination about cells. And if you know that technique to solve problems, or if you can use the technique of combination of cells to solve problems, then very long problems you can make it or reduce them to very short problems. So, first I will discuss the formula derivation, and then I will show you how to apply those formulas to solve problems effectively. So, first we will go for series combination of two cells. So, a cell will have an EMF E and an internal resistance R. So, that can be drawn like, so as a cell having EMF E and internal resistance R, that can that is equivalent to an ideal cell E and resistance R in series. So, this is the whole package, the whole combination. This is equivalent to this. So, now cells in series, first I will discuss series. Suppose you have two cells. So, this is E1 resistance R1, this is E2 resistance R2, and you know the potential difference across the cell, this ideal cell, is equal to the EMF. So, suppose this is a series combination and the current I happens to flow from in this way. Now, we will like to replace these two cells by one cell, so that the potential difference between points A and B is same, and also the same current I is going to flow through that line. So, this is equivalent to, so this is point A. So, these two cells replaced by one cell and one internal resistance R. So, this E is the EMF of the equivalent cell and R is the internal resistance of the equivalent cell. So, this will carry the same current I. Now, that is A, B. So, let us name these points. So, this is C, and say this point is D, this point is E, and again B. So, VA minus VB, we can write VA minus VC plus VC minus VD plus VD minus VE plus VE minus VB. Okay. So, VA minus VC, this is an ideal cell, right. So, E1, you know the plus plate has higher potential than the minus plate. So, E1, so VC minus VD, so VD minus VC is I times resistance. So, this will be minus I times R1 plus VD minus VE, this is the plus plate and minus plate. So, this is plus E2, and then VE minus VB. So, current flows from B to E. So, this will be minus I times R2. So, that is, this is E1 plus E2 minus I times R1 plus R2. So, that is VA minus VB, right. Now, let us look at the equivalent circuit, which has only one cell and one resistance, simple as that. So, VA minus VB, just make one more point here, say F. So, VA minus VF plus VF minus VB. What is VA minus VF? That is E, and VF minus VB. VB minus VF is IR, we know from Ohm's law, and current flows from B to F. So, minus IR. So, that is VA minus VB. Now, we can compare this equation and this equation. So, what do you get? this E is equal to E1 plus E2 and the resistance R is equal to R1 plus R2. Right. So, here these two cells are having their positive place in the same direction. If you reverse, say if suppose the plus plate of E2 is towards the right, then what is going to happen to the formula? See, I will make this in this diagram itself. So, that is E2. Now, there will be subtle changes in this. So, now VE minus VD happens to be E2. So, there you will have a minus sign, and will you have any other sign changes? No, not really. See, this VE minus VB remains a minus I times R2. So, here the sign will be changed only here, and while for the equivalent circuit, the equivalent cell resistance, you will have the same formula. So, only one thing will change here. So, E1 minus C2, resistances will be added, right. There is no question of subtracting resistances, as you see from the derivation. Okay. So, in the same way, if you have 3 cells in series, 4 cells in series, similarly you can know actually from this formula, if you have 3 cells. So, it will be E1 plus E2 plus E3 if the cells are in the same direction, or you have to subtract, right. So, that is all about series combination of cells. Now, we will deal with parallel combination of cells. So, here 2 cells having EMF E1 R1 and E2 R2, so E1 and E2 the EMFs and is R1 and R2 as the resistances, they are combined, so that you have such a circuit. Then the current coming from here is I and current here is I1, this current is I2. Now, this whole package of 2 cells, I want to replace it or reduce it to 1 cell and 1 internal resistance. So, this will be the equivalent circuit having one EMF and 1 resistance, that is 2 cells, combine it to make 1 cell. Now, let us name the points. Here the point is A and here the point is B. So, for the equivalent circuit, here the point is A, here the point is B, and obviously current flowing is I. And again the whole logic is same, that VA minus VB in this left figure is equal to VA minus VB in this right figure. So, what is VA minus VB here? So, here VA minus VB, see from this top branch we know it is E1 minus I1 R1, right. How do you know that? How? Because suppose, see again the same logic we have applied, let us give it a name C. So, VA minus VB is VA minus VC plus VC minus VB. What is VA minus VC? So, this is shorted, so this is also point A, right. So, VA minus VC is E1, while VC minus VB is minus I1R, because current is flowing from B to C. So, that is, and this same VA minus VB you can write from this lower branch also, that will be E2 minus I2 R2. Now, in this figure VA minus VB is equal to E minus IR, that is plain and simple. Now, here as you know I is I1 plus I2, so we will make use of that. So, to make use of that, what we will do here, so this is, so we will divide the numerator and denominator by R1 here, and this also by R2, E2 by R2 minus I2 divided by 1 upon R2. So, that is VA minus VB, right. So, VA minus VB is both this ratio and this ratio. So, we can add the numerators and the denominators and the ratio remains unchanged. So, this is known as addendo, as you know. So, we are going to add the numerators and the denominators. So, E1 by R1 plus E2 by R2 minus, see I1 plus I2 will be I. Now, we will have to add the denominator as well, 1 by R1 plus 1 by R2. So, VA minus VB happens to be this, E1 by R1 plus E2 by R2 by 1 by R1 plus 1 by R2, this whole thing, minus I times below here you get 1 by R1 plus 1 by R2. So, now we have to compare these equations. So, that is VA minus VB. So, we have to compare these equations, this equation, that is also VA minus VB. So, after comparing we get E is equal to this whole term and R, or rather 1 upon R is this, because this you can write as E minus I divided by 1 upon R. So, after comparing you get E is equal to E1 by R1 plus E2 by R2 divided by 1 by R1 plus 1 by R2, and 1 upon R is 1 upon R1 plus 1 upon R2. So, that is the formula we get. Okay. So, this is for two cells in parallel combination. Now, if it happens to be so that, so instead of the plus side toward the left, the plus side is towards the right and minus side is towards the left, then the formula will change. What will happen? Only you have a negative sign. So, in place of E2 you have to substitute